Hello and thank you. My name is Hamid Montazeri and I'm the Director of Software Engineering for the Digital Accelerator part of Stanley Black & Decker. And I'm really pleased to have the opportunity to share with you the journey that we've been through in the past 2 years with the help of Aaron, who is the CTO of one of our partners, ClearBlade. So let me start by introducing Stanley Black & Decker to you. Most of you probably have heard of the name. We are a diversified industrial that are organized along 3 verticals, 175-year-old company. The biggest vertical that we operate in is the tools and storage business, where we are #1 in the world. And we manufacture and create the type of tools that a lot of customers use to create their own and manufacture their own products and go for creation of new buildings and construction environments. The tools and storage business is the home to such well-known brands as DeWalt, Stanley, Mac Tools, Protocable, Bostitch, Black & Decker, and with the recent acquisition of Craftsman also. As you can see, there's a lot of things in there, and there's a lot of opportunities to apply the Internet of Things. While the tools and storage business is about 65 to 70% of the company, we have significant presence, $1 billion plus, in 2 other verticals. One vertical is the world of security, be it commercial security, electronic security, or mechanical access. Over there, we are the home to brands such as Stanley, Sonitrol, Aeroscot, and Hogs. Hogs is an interesting brand. The Hogs business unit allows security for newly born infants. In fact, it has one of the older IoT systems in practice that have helped to secure infants in many hospitals. The industrial vertical has 2 components. We play in the world of infrastructure, and we also have a significant presence in the engineering fastening world. In fact, most of your electronic devices have fasteners that we create. The digital accelerator's role within the Stanley Black & Decker is to foster adding more digital to the DNA of the company and pave the road for the world of IoT. We were created about 2 years ago, and we were located in Atlanta, separate from most of the power centers in the company so that we can keep independence and work like a small startup. So with that said, let me ask Aaron to introduce himself and ClearBlade.
Thank you. It's a pleasure to be here. It's exciting to be at IoT Evolution Expo. Thank you for having us. My name is Aaron Allsbrook. I'm CTO at ClearBlade and the architect of our products. I have been in the application enablement space my entire career, beginning as a developer building tools and runtimes for others to use, as a practitioner building solutions, enhancing solutions, modernizing solutions that were already in progress, and then a lot of architecture role, helping select devices and protocols, choosing security models, scalability challenges. All of that has been in the context of enterprise and large organization, helping to connect up the business, to engage with customers, and ultimately integrate the existing enterprise into those overall solutions. A little quick intro to ClearBlade. ClearBlade is an IoT software company with products for IoT cloud platform, IoT on-premise platform, and IoT edge platform. These platforms allow large companies like Stanley to very rapidly build IoT solutions and empower their business the different ways they want to do that. It's very often not just about building a new one solution, but it's how do you engage the existing stuff, the factories that are out there, the brownfield that's in place already. So I'm excited to be here today. We're going to talk a little bit together. Hamid's going to give the insider view, obviously an insider in what's going on there in that digital accelerator with IoT. And I'm going to take from the outside view and do a little bit of history, because it's certainly been 2 years working together. And so much of what's going on in IoT is how can we learn from each other, and I'll share the things that we've learned together.
Thank you, Aaron. So that was a great introduction. Hopefully, during this talk, you can see the perspective from the client, in this case, Stanley Black & Decker, trying to put together its own IoT platform, and the perspective from one of the partners and the work that we did together. To motivate the discussion, let me show you a slide that depicts the predictions that you have already heard or seen in the literature. between 25 to 50 billion connected devices by 2020. It's a large number of devices. In fact, if you get the boxes and connect them together, you'll probably get to the orbit of Pluto. And about $4 to $6 trillion of revenue opportunity. Again, a massive number, and that's why a lot of companies participate and focus in this field. With that said, we wanted to talk a little bit about one of the pieces of research that Gartner did. What they discovered was that 62% of the companies that are active in the world of implementing IoT do the type of work that we do at the Stanley Black & Decker. They lead their own developments and they work with partners such as ClearBlade in order to achieve their vision. About 79% of these companies are very much focused on preventative maintenance. Preventative maintenance has been one of the low-hanging fruits that a lot of companies go after. And about 80% of these companies collect data generated by their devices, by their connected devices. And when Gartner asked them, why do you want to do IoT? The two top answers that they gave was that IoT allows them to come up with new revenue generation mechanisms, and it also allows them predictive maintenance. And now again, that's their preventative and predictive maintenance showing up again. And they also indicated that they often collect data that indicates time, location, and some physical quantity, as well as the way the users use a particular feature. So with that in mind, let us look at the application categories that we see in the world of IoT. Typically, we see two categories. On one hand, we see companies IoT enabling their products. So maybe you have a tool that we at Stanley Black & Decker IoT enable for multiple reasons. Appliances, vehicles, and heavy machinery, those are other examples of enabling individual tools or individual products. The other category that is a much more complex category is creating digital workplaces. And in this particular category, we look at having a number of tools or devices work together in order to make an environment IoT enabled. Examples are factories, homes, industrial warehouses, and farms. So how do you get started in the world of IoT? That was a problem that we looked at for multiple business units that came to us and wanted us to help them. We found that there are four steps that you want to kind of move along. The first one is to identify the opportunities, of course. And certainly customer needs, voice of customer is important here, and marketing research is very important here. But never forget about innovation. There's a lot of things in the world of IoT that you can do by thinking out of the box, and it's really important to have your innovation hat on. The second part is to actually develop technical competency. As a company, you really need to know what's going on. The world of IoT is a vast arena of different technologies. You need to know about a lot of them, and you need to be able to define guiding principles as to how you want to put together your platform and your business, and then define for yourself basically layering, architectural layering that you can use, and finally keep track of technology as it's evolving. There's a lot of technology that changes. The next step is to select partners. Again, because the world of IoT is so fast, no single company can do everything. So you can't just do it all yourself. You need partners in most cases, and you need quite a few partners. And a great way to select partners is actually to do proof of concept projects with them. Through the proof of concept projects, you can figure out the technical ability of your partner. You can find out the synergies in technologies and in culture, and make sure that you can work together and you can create your vision. You can also use the proof of concept to influence your partners. A lot of times, partners are thirsty to get feedback and change their products in a way that is useful for both of you. And finally, you want to start executing on projects. Just talking is not enough. As usual, and you just heard from John, you want to start small, but think big. By starting small and delivering code, as you know, working code always wins. You can prove the principles that you have set forth and convince the company that it's the way to go forward. There's a lot of integration in the world of IoT, so you want to make sure you integrate early and often and to flush out all sorts of issues that may come up. And finally, you want to learn and adapt as you do execute your projects. With that in place, let me look at some of the guiding principles that we had when we looked at the vision for our own platform. We found that we had 5 pillars that we wanted to put base our vision on those. The first one was security. Nowadays, there is not much reasoning required for talking about security. It goes across the domains. There are many examples of what problems can come up if you don't do security, and you read about it in the media. We wanted to have an open environment, wanted to leverage open source and have an open platform that people could integrate with so that we could replace technologies if needed, language if needed. Being open was important for us. IoT is all about being distributed. You have a lot of sensors and actuators and edge devices that are spread over a wide area. So the system needs to be following the well-known distributed system design. It has to be reliable. You heard about hugs and the fact that you want a secure fence. There are health and security applications where you can't tolerate the fact that there is no connectivity to the cloud potentially, or you have a network split. And finally, you want to be scalable because there are hundreds of thousands of sensors and actuators that you're going to connect together. So when we looked at the stuff, we came up with a layering system that you can see also in the literature as well. We have our own twist on it. Basically, you can see horizontal lines that define concerns that are self-contained, and then there are three main vertical cross-cutting concerns. The cross-cutting concerns are typically security, billing, and monitoring. You need to monitor your system, you need to be able to bill for your internal and external customers, and you need to be able to provide security. I'm going to talk briefly about these layers, and every single one of them one can allocate a whole session to, but it would be instructive to kind of look at them from our perspective. The very first layer I want to talk about is the connectivity layer. And the Internet of Things, of course, is all about connectivity. But in the world of Internet of Things, connectivity is not just limited to Wi-Fi. A lot of devices have Wi-Fi connectivity, but you need more than that. For example, a lot of products nowadays use Bluetooth Low Energy in order to pair with a phone and then use the phone as a gateway to send data to an IoT backend. So we do have Bluetooth Low Energy that you need to kind of look at. A lot of applications, however, are very battery sensitive, and there are also in an environment where connectivity is not there. So there are emerging standards in basically low power wide area networks such as LoRa or licensed LPWA. All these things are emerging, you need to keep track of it, and they have applicability in the areas that you may encounter. The next two layers are interesting layers. They talk about device management and having edge and fog computing. Device management is all about having remote access to your devices. A lot of times you need to update the calibration on a particular device, so you need to have remote access to it. You may want to change the configuration on the device. Frequently, you have to do over-the-air updates. In fact, most of the IoT systems, if they don't have over-the-air updates, there is something missing in them. Sometimes you want to do over-the-air firmware update. Occasionally, you want to rotate your security certificate. So it's really important to have a device management layer. There are systems that deal with it. There are governance rules that you need to have in your organization. So it's kind of a very important layer to pay attention to. Next, there is edge and fog computing. A lot of IoT systems are very sensitive to latency. You can't always go to the cloud and come back. So it's very important to have solutions at the edge, maybe in a factory that is not connected to the cloud, or the connectivity is very spotty in that factory. That way, you can react to the data that your sensors gather and generate your control inputs locally. The next two layers that I want to talk about relate to application enablement and analytics. Not come up to the level where we're looking at integrating with our system and showing results out of it. IoT systems are all about message passing. They are message-oriented systems. So you want to make sure that you have a system that is solid in terms of handling messages coming through well-known protocols, such as MQTT or HTTP. A lot of times you have to have a rules engine so that you can immediately react to information and data that comes through your sensors. And finally, you want to have this notion of virtual device, the digital twin. In many distributed systems, it's actually critical in making sure that data corruption is avoided. At a higher level for analytics, you want to make sure that you can provide visualization and maybe reporting and real-time reporting using artificial intelligence and machine learning and those sophisticated capabilities. and you want to expose API for creating an ecosystem where other people can integrate with your system. So with those in mind, we started working with many partners, including, in this case, ClearBlade, to do proof of concept projects. The first proof of concept project that we did was to look at how we can gather location information. John was talking about the project that Amazon had. Location information in many IoT applications plays a central role. And we wanted to combine that with information that came from enterprise systems so that we could have a trajectory of how a particular object was traveling through our systems. That we wanted to kind of do on-premise using an edge solution, and then send that to the cloud and show the results to the users and provide analytics on it. This is a proof of concept that we did with ClearBlade in about 2 months. It showed a lot of capabilities, showed some of the things that we needed to improve on, and was very instrumental in our understanding of how we could work together and build our platform. The next proof of concept that we did with ClearBlade was based on our access management systems and tools. Again, this was a new protocol using Modbus to send data over to an edge solution because we needed to detect changes in the access management. The door opens or closes immediately and react to that. And then when the opportunity was there, to send it to the cloud so that we could apply big data and analytics to it and show the results using sophisticated modern web technologies. It was another very successful pilot project. We did it in 2 months. It created a lot of learning and understanding for us and helped us mutually to figure out how we can go forward. So with that said, I want to kind of turn over to Aaron to kind of talk more about these use cases at a distilled higher level and how they saw the interaction from their perspective.
Great, thank you, Hamid. When we look at where Stanley is today, they've taken these guiding principles, openness, security, distributed, scalability. All of those guided principles today are encapsulated with their IoT platform. This IoT platform that they can take, they can reuse across their business units, scale with their business units, enforce security with their business units, but yet then still do this integration, this user experience, whether it's on an Echo or an Apple Watch or an iPad or on a web page. The vendors who are going to come in and do positioning with ultra-wideband or BLE or RFID, moving those folks in and out as needed for best of breed. The integrations, the stuff that one business unit figures out that another business can reuse, or the machine learning, the analytics, the intelligence, pushing that off to the best of breed cloud vendor or on-premise, wherever you want to do it. Ultimately bringing intellectual property in that they own and running and tying all this together. So this is a great view of where you are today. But 2 years ago when we started this conversation, right, this was what we were hoping to achieve. And so, when we started and you asked for, let's do 6 different apps across 6 different verticals to prove out what's the right way to do this, we certainly had some interesting conversations. But if we go back in time and look at 2 years ago, the first thing that Stanley communicated to me was, we actually know a lot about IoT. Stanley has multiple IoT products, and 2 years ago were best-of-breed products, whether it was in healthcare, whether it was in manufacturing, whether it was in energy and oil and gas. They had a number of solutions that were ranked by analysts and vendors as the top in their marketplace. They knew a lot about this. They had been doing their homework for a while. So 2 years ago, they knew it was going on. They also had been doing their digital innovation. So the digital accelerator was new in existence at the time. And this group wasn't about just building solutions. It was about how do we focus on the business to give the businesses that we have the power and need they need. They specifically hit on speed and efficiency. Pilots that take 2 months, that's important. How do we get there and try this stuff out? How do we enhance the products we have? We don't want to throw away what we've got. We've got to work with this and enhance what we have. Engage our customers, and ultimately, Stanley's a big company. There's lots of folks to bring together. If we can, increase the power of that, get the reuse, collaborate, there's a lot of opportunity. So, that's what they came with and why they presented to us in sort of beginning. And really, when we looked at what the challenge they had with what was going on, it was really about the ecosystem. It was slow. There was pain points of making two things work together. Finding the right people within the organization to help was expensive. Upgrading their customers to new things wasn't nearly what they wanted it to be. The experience, serving the customer, like we just heard, as being so important, wasn't what it was. And the last one, which was pretty big, is the lost opportunity. And this is something that Stanley's customers could actually explain very well right back to them. They could very much say, I own the small tool solution, I own the big tool solution, I own the access management solution. If there was a story here, I would get a lot more value of all these things that I've bought from you. And not being able to get that opportunity, that ROI of tying these tools together or tying these solutions together was a big part of what they were seeing as a challenge. I think this is important because it's not just Stanley. Stanley's got lots of verticals, but this exists in smarter buildings or connected buildings. How do we connect power management to building management systems, to lighting, to residential services? It's an ecosystem challenge. We look across other groups, other industries, transportation that's coming in, or insurance. Insurance is trying, how do we connect the home and the automobile manufacturers, all these different things together that are on their own right solutions, but bringing them together in a common way. That's what Stanley came with and wanted to address. And they really brought, I guess, three core principles when they began talking to us. The first was a developer focus. We just heard this. I think it's cool you guys are right on track, except 2 years ago. How do you self-serve your developers? How do you empower your partners, your integrators, your internal developers, your digital accelerator developers to do what they want to do quickly on their own? Give them a platform that they are empowered to work with. Obviously, API first, let it be an integration kind of model out of the box. But the other core tenet is we've got a lot of developers and a lot of different tool sets and processes that are working today. Don't break them, right? We got a group that does Microsoft. They want to keep working in Visual Studio. They want to keep working with their Allen Bradley OPC mechanisms. Keep that in place, work with those tools and processes. We've got Jenkins for our DevOps processes, keep it going. We've got Bitbucket for our change control. Let's make sure our processes work. So that first thing was extensibility of making the developers' lives easier. The next thing they said is you can't pick any technologies and force any technologies on us. That's a hard requirement. But ultimately what that meant is there is going to be a constant evolution of best-of-breed hardware and devices. Stanley wants to be able to engage those ecosystems. There's going to be a constant movement of what's the best programming language, what do our developers know, what protocols do we want to use? We heard MQTT, we heard HTTP, but there's a whole plethora out there that are continuing to go. So we had to make sure that their platform could support this ecosystem of lots of different things and enterprise software vendors. The final one was a little counterintuitive at the time with regard to developer focus, and that was it had to be metered. That's incredibly important in our day and age of how do we start making new products. If you're going to do as a service product, you have to be able to meter in all sorts of new and unique ways. It could be per device, per drill. It could be per transaction. So how much do you use the drill? What kind of data are you doing? How much compute does it take? It could be how many times did you turn the screw, right? We don't know what their businesses are going to want to do. You don't know what your businesses are going to want to do, how they're going to want to go to market. So it had to be a very metered, focused approach to what they wanted to do within their own platform. Developer focus was important. The next thing that I see, and I heard it at Stanley, but I hear it lots of folks, specifically smarter cities, are very concerned about future-proofed based solutions. It is very kind of paralyzing if you think that you're investing in technology today that won't be valuable in the years to come, especially when you look not just next year or the year after that, but 5, 10, 15 years. The first tenet of future-proofing is being extensible. That means you can add. You've got a framework in place where you can put new functionality in, and you can grow the solution. So That's one of the core tenets of how do they put this platform together is they can move it and they can add to it over time without breaking what's there. The next piece is unopinionated. And I love the drone photo because right now we all have opinions about drones. They're pretty cool toys, right? And so if we were to be very opinionated about them now, we'd put them into a thing that we can fly and be up and down, and that's kind of how we view them. But the future of drones isn't about being a toy. It's about having a camera and being an actor in a security system or being an actor in a surveying system. And there's going to be all sorts of views and understandings about that thing coming forward and in the future that we need to be ready for and ready to manipulate around. So the platform itself that they wanted had to be very unopinionated. And of course, portable. If you're a smarter building, or if you are doing transportation, you may be thinking about, well, today we want to run our solution on one place, but we might want to move it on premise later for our security version, or we might want to just move it because we like to make sure we can move it, right? I don't know what the reasons, but you have to be able to do that if you're going to have longevity out of the solutions that you build. Continuing future-proof and that portability was all about deployment. 2 years ago, Stanley's asking, show me how you do the container-based deployment. Show me how you can stand this stuff up, scale this stuff up, move it to any cloud that you want to do, leverage different cloud services for when AI is best here versus compute's best here. How do you handle that deployment and make sure we're flexible, future-proof us against these changes? And then the on-premise, right? Cloud's awesome. We see a lot of work going there, but there's still the use cases of let's keep this behind our firewall. This is healthcare data. This is in our hospital. This is critical to our business. Let's keep it close. So that's part of what the requirements sat at. And then I'm excited about the next session after this, but open standards, being part of the open community was core to what Stanley was working to do. Why do you want to do standards in the open or in the space of future-proofing? It makes it much easier for others to adopt. You've got an existing community ready to join in and be part of it. They can contribute on their own. And then ultimately, really, when you look at what you wanted to do with the integrations between your tools, were they using open protocols? Were they using those open standards from those solutions? They would have had it out of the box ready to go. The last piece, and we alluded to it, I think, in the opening, had a lot to do with where I think Stanley was probably the most future thinking about IoT in general. 2 years ago, Stanley very clearly articulated the need for a full platformed edge that could do every bit of their IoT solution running on the gateway, running in the factory, running in the rural remote environments. The full function of the edge meant the security model had to be there. Security out of the gate. Stanley's always talked about we don't want these devices that we make at large scale being vulnerable. So the security model had to be at the edge. The full capability for doing the AI, the machine learning, the studying of the data, the raking the data, the grooming the data, the logic of everything that needs to happen should be able to run at that functional edge. They had two non-functional requirements that went along with that edge. The first was for the performance. They wanted the ability to take brownfield machines, talking legacy protocols, all communicating in real time at tens of millisecond speeds with other devices like the BLE and the new emerging devices. So the idea of this highly performant, sensitive to basically time constraints in their use cases, being able to do that all at the edge. Especially the access is a great example of where they need to be able to make sure that they are able to notify the right people, alert the right folks when, say, the nursery's been impacted. The final requirement is about the uptime. It's so important to make sure that if we're going to introduce IoT into our existing factories, our existing manufacturing, our existing warehouses where we have SLAs, where we have requirements to keep uptime, we can't introduce new failure points. We need our IoT solutions to stay up 100% of the time, and then when they do go down or we lose connectivity to the cloud, we need them to recover. So very much all about how do we guarantee the stability of our IoT solutions by leveraging the edge architecture. And if you look at that and what Stanley's been able to do, they've been able to give themselves a core IoT platform that lets them engage their developers very quickly, being developer-focused, lets them innovate, protects them from a lot of the constant change we're still seeing in IoT, and able to adapt to new protocols and enrich their current solutions, and then ultimately have an architecture that scales incredibly well, and scales to huge levels, and gives them the full stability and function they actually need for all of their solutions. Hamid, before I hit the next button, anything you want to add?
The only thing I wanted to add was, because the field of IoT is so new and emergent, there is ample opportunity and need for actually working with the startups, because they tend to be the vanguard of new technologies and working on that. So I really recommend everyone who's working in the field of IoT want to partner with companies to actually look at the startups as well. That's a great way to get access to new technology implemented in the right way. Thank you.
Thank you.